Section 7.2 here. The I can statement is I can multiply binomials. Binomials. I can multiply binomials and then simplify the result. Quick little warm-up here, just some vocabulary to start off with. What do we call the number in front of a variable? Hopefully you know what this is and how to spell it. Coefficient. Coefficient. And then what do we call a plain old number? No variable attached to it, no expression or anything weird like that. We call that a constant. Plain old number is just a constant. And then down here it says multiply and simplify. Now, you've seen problems like this. We did one in the last section that was very close to this. We distribute the 3x through to both of those things in parentheses. We don't multiply these other two terms by that 3x, that factor out front, because they're not in parentheses. It's just 3x times what's in parentheses. So this is going to give us 6x squared. This is going to give us minus 12x, and then we've got the minus 4x, and then the plus 2x, and then, 2x squared, and then we'll go through and we'll collect like terms here. So those two are like terms, so we're going to write that first because it's got the highest exponent. We're going to write these in descending order. So we write this down as 8x squared, done with the two of those, and then I can put those together, and I end up with negative 16x. We'll go ahead and circle that. And then distributing through here, now I want you to take a look at how ugly this is. We've got a whole bunch of stuff here. We've got a coefficient in front of x, coefficient in front of y. We've got an a term, a b term, and then we've got this constant at the end. And then what we're going to do is we're going to multiply the a through to every single one of these. So this is going to take a little bit. But what I want you to notice is there are no like terms inside here. So this is simplified. If we could simplify something in there, we probably would. But here's what we get. We get 6ax. I'll go ahead and write them in alphabetical order. And then plus 4ay. Multiplying here, we get minus 5a squared. Minus 10a squared, sorry about that, minus 10a squared, and then we get minus 8ab, and then the last one, when we multiply the 2a times the constant of 8, we end up with a plus 16a. Now, there's nothing really that can be done with that. We could argue about the order there and say, hey, maybe the a squared term needs to go first or something like that. But remember, there's not really a good rule about what order to write those in. So let's go ahead and take a look at what we've got here. Quick little paragraph here talking about what we call expressions. So if expressions have one term, then they are called a monomial. Monomial. Let me get an N right there. Monomial. Okay, they're called monomials. Expressions that have one term are called monomials. If they have two terms, they're called binomials. Binomials. Three terms, you might be able to guess. It's called a trinomial. Trinomials. And then after that, we just call them polynomials. Polynomials. Okay, so mono for one, bi for two, tri for three, and then polynomial. Again, that's just kind of a generic term for anything that has four or more terms. We could actually call any one of these a polynomial, except for that monomial there. Now, in the warm-up, what we were doing here is we were multiplying a monomial through to what's in parentheses. Every term inside, every single term on the inside, got its turn being multiplied by that factor on the outside. And we can apply the same idea when we're learning how to multiply binomials. So I'm going to slide down here. We're going to go ahead and take a look at a couple of these examples. So here's what we would do on this. We've got two terms here that need to be multiplied with the two terms in here. So what we're going to do is we're going to take it a turn at a time. This x gets its turn being multiplied with each one of those. So I'm going to draw those distributing rules right there. So if I do that, I get x times x. That's x squared. I'm going to do x times 5. That's going to be plus 5x. Again, notice that we're writing them in the correct order with the coefficient out front. Then we're done with the x being multiplied with each one of these. Now it's this one's turn. It's the negative 4. So include that sign there. That negative 4 gets distributed through to both of those. And we get a negative 4x. And then a negative 4 times a positive 5 is a negative 20. Now you'll notice that we've got four terms here. There should be something nice about that. Two terms here times two terms here gives us four terms. But you'll notice that the two terms in the middle, these two are like terms. So let's go ahead and combine those because we not only want to multiply these two binomials, we want to simplify the result. So we get x squared. We're done with that one. If we put those together, 5x minus 4x is just an x. I'm just going to write instead of writing 1x, I'm just going to write x. Done with the two of those, and then we've got that constant at the end. We've got the minus 20. Circle that and we're done. That's literally all there is to it. Now let's turn our attention to this one right here. So again, we're going to multiply the y by each one of these. Then I'm going to multiply the 2 by each one of these. So we should end up with four terms again. Binomial here, two terms times two terms is going to give us four terms. Y times y is y squared. y times 6 is 6y. Again, notice the sign there. Positive 2 times y, that's going to be plus 2y. And then I've got a 2 times 6, that's going to be a plus 12. Again, notice that I've got the right sign in front of everything. The one that comes first, I don't have to write that sign. That's just by convention. So we're going to write down y squared. We've got that one. And then those two are like terms. We combine those together and we get 8y. Done with those, and then the only thing left is the constant at the end. That really is it. All you need to do is be careful that you make sure that you get every term in the first one multiplied by every term in the second one, and then just make sure that you've simplified correctly. Make sure you don't make any sign errors or things like that. So I'm going to go ahead and draw these lines because I find those to be really helpful. So we're going to go 4a times 5a. That's going to be 20. a times a is a squared. 4a times 6, that's going to be 24a. Then negative 1 times 5a, that's negative 5a, and negative 1 times 6 is going to be negative 6. Again, like we've seen before, and these are relatively simple to start off with, you'll notice that we've got some like terms here again. There's only one a squared term, it's the 20. We put the two of these together, we get 19a, and then we've got that constant on the end of 6. We go ahead and circle that and we're done. Now, these next couple, a few of these are a little bit challenging. They might have some surprising results, so let's go ahead and take a look at this. On this one, we've got a negative 7r minus 5 in parentheses. So here's our binomial here, and a negative 8r minus 4. You'll notice that we've got a ton of negatives floating around here, so we're going to need to be really careful. So when we multiply here, negative times negative is a positive, so we're going to get 56r squared. Negative 7r minus, or times negative 4, that's going to be plus 28r. We've got negative 5 times negative 8r, that's going to be plus 40r. And, oh, I forgot to draw the lines right there. Okay, kind of getting carried away here. So we got the 7 times the 8, good there. The 7 times the 4, good there. Of course, we're dragging those r's along for a ride. And then we've got a negative 5 times a negative 4, so that's going to be a plus 20. Bigger numbers, had more negatives to keep track of, but lo and behold, because there were so many negatives in here, look what happens. Everything there's positive, so I get 56r squared. Done with the two of those. This is going to give me 68r. Done with those guys right there. And then we're going to have a plus 20. So we'll go ahead and circle that and move on to the next one. We've got 3x plus 2 as the first binomial times 3x minus 2. So again, the 3x is going to get multiplied by both of those, and then the plus 2 gets multiplied with both of those. 3x times 3x, 9 for the coefficient, x squared for the variable portion. And then we've got 3x times negative 2, that's negative 6x. 2 times 3x, that's positive 6x. And then 2 times negative 2, that's going to be a negative 4. Now we've got those 4 terms that we were looking for, and notice that the middle terms are like terms, but notice that one is a negative 6x, the other one's a positive 6x, so those are going to cancel. That means we've got a 9x squared minus 4, and we'll go ahead and circle that. We're done there. Kind of an interesting result. And then let's take a look at this one. This one says 2v minus 1 times 2v minus 1. So the 2v times each one of those. So that's going to be 2v times 2v, 4v squared. 2v times negative 1, that's negative 2v. Negative 1 times 2v, that's negative 2v. And negative 1 times negative 1 is positive 1. Again, we've got some like terms right there. So we've got the v squared term. There's only one of those. Those two, let's see, we have negative 2v minus 2v, so that's going to double up, and that's going to be negative 4v. And then, of course, the constant on the end. Now, that takes care of the bulk of the type of problem that you're going to see. You're not going to see anything more difficult than that. But I do want you to take a look at example F right here. Could we apply those same ideas when we're multiplying a binomial and a trinomial together? So we've got a binomial, we've got 2 terms here. A trinomial, we've got 3 terms here. Could we apply the same ideas? So let's take a look. If I multiply here, here's what we get. Multiply here, here, and here. If the 3x takes its turn getting multiplied with each one of those, here's what we'd have. We'd have, let's see, that's going to be a 12, and then x to the third, so 12x to the third. If we multiply 3x times negative x, that's going to be negative 3x squared. And then we take the 3x and we multiply it by negative 5, that's going to be negative 15x. So what we've done is we've multiplied each one of these by 3x. Looks good there, okay? And then we're going to take the 2 and we're going to multiply it by each one of those. So this is going to be 2 times 4x squared is going to be 8x squared. 2 times negative x is going to be negative 2x. And then 2 times negative 5, that's going to be negative 10. Then we go through here, and before we go and simplify anything, let's take a look here. 1, 2, 3, 4, 5, 6 terms. Remember, there were 2 terms in the binomial times the 3 terms in the trinomial. I mean, it really shouldn't be any surprise that we end up with 6 terms. Now we just want to simplify. There's only one x cubed term. It's right there, so this is going to be 12x cubed, so we're done with that one. We do have a couple of x squared terms, so negative 3x squared plus 8x squared is going to be plus 5x squared. Done with those. We've got a couple of x terms, so that's going to be negative 17x when we put the negative 15x and the negative 2x together. Done with those, and then finally that constant at the end. So we end up with a very long, ugly polynomial. We've written it in descending order. Notice the exponent goes from 3 to 2 to technically a 1 right there, and then the constant at the end. Okay, now a thought experiment. Do you notice any patterns in the coefficients and the constants when we're multiplying these binomials? Now, you don't have to do this. You're not going to see anything this ugly, but I do just want you to look and watch, okay? So the self-assessments at the bottom of the page, you can do that if you want to right now, but I'd like you to take a look at this. We've got a binomial here times a binomial there. Now, reminder, normally we use letters at the beginning of the alphabet to represent constants. So this is like a coefficient out front. This is a number in front of the x plus a number right there. So that one counts as a coefficient, that one counts as a constant. Same thing here. So watch what happens here. ax times cx would be a times c times x squared. It's one big long multiplication problem. We've got 2 x's in there, so we write that down as x squared. Then we have ax times d, so that's going to be a dx. And then we've got b times cx and b times d, so this is going to be bcx when we multiply those 3 together, and then plus bd. Now, you'll notice that this one right here, that's just numbers multiplied together, so that's going to be a constant. You'll notice that this one right here has a square on it, so that's the only squared term. So I'm going to write this. I'm going to write acx squared. We're done with that one. This one's going to go on the very end because it's just plain numbers, but I want you to take a look at this. We've got this many x's and that many x's. So here's what we would do. We would normally, if we had something like this, let's say we had 5x plus 3x, we'd add those two together and we'd write it down as 8x. Well, what we really did is we said 5 plus 3, and then we put the x on the very end. So let's do this. AD plus BC times x. Put the x on there, and then we'll finish it off with BD. Now, that is a very complicated looking expression, but the thing that I want you to notice is these 2 terms in the middle right there, just like all of those other ones up above, we ended up having some like terms. Those were like terms, those were like terms, those were like terms, and there's a relationship between the numbers that were up here in the binomials to begin with and where those numbers work out in the end, like this 9, this 4, this 20, this 56, and stuff like that. So not a big deal, just something to get in your head, have it cook there. Good luck on the assignment, fill out the self-assessment, and you're good to go.